All right, it says carry out each indicated operation. Explain why it can't be performed later. All right, so if you look, right, this is the form, and I said it yesterday, but this is most likely the format you'll see this on a quiz or a test, in which it will give you the matrices at the top. There will probably more than 2 by the time we get to that. It could say A equals B equals C equals whatever it is, and then it's going to give you the things to do past that. So before you even get started on this stuff, you want to make sure it can be done, right? If it's like number 1, where it's a scalar multiple, it can always be done. So I just take the 2 and I'd multiply it in on all 4 spots on A. So I'd get -6, +10, 14, and 8. On 2, it's -3B. So we take -3, multiply it in on all 4 spots on B. I get 9, -18, -6, and +3. And then you get to the addition. So the addition, what has to happen in order for you to be able to add them? You have to be exactly the same dimensions. These are both 2 by 2, so we're good. -3 plus -3 would be -6. +5 and +6 would be 11. 7 and 2 would be 9. -1 and 4 would be 3.
That's only for addition.
Addition and subtraction.
But multiplication is
No,
another.
multiplication, it's the inner 2 that have to match, and then the result's the outer 2. Yep. All right, so then 2A minus 3A. We already have 2A, right, which is -6, 10, 14, 8. And then -3A can be done and then add them, or I can distribute a +3 and subtract. So you have those 2 options. I'm going to do the +3 and then subtract. So this would be minus -9, 15, 21, 12. And then I get -6 minus a -9. That becomes -6 plus 9, which is 3. 10 minus 15 is -5. 14 minus 21 is -7. And 8 minus 12 is -4. Uh-huh.
There was one on the homework that it was multiplication and it was 1. So how did you do that?
You would only be able to, you have it by, it was something by 1. Yes? Can I finish this and then we'll go there? Yeah. All right, so for A, this is again a 2 by 2 and this is a 2 by 2. So to go A times B, I have to match the middle 2. They do match. The result is going to be the outer 2, which is a 2 by 2. So for the first one, it is row 1, column 1. Row 1, column 1. So I get -3 times -3 plus 5 times 2. So 9 plus 10, or 19. Then it's row 1 and column 2. So I keep the row 1 from A, but I change it to column 2 for the B.
Where did you get the 2 from on row 1 column 1?
It's not a 2. Wait, the second one?
Yeah.
This one?
Yeah.
It's the second and the second. You go across and then down. All right, so for row 1, column 1, it's -3 times 6 plus 5 times -1. So I get -18 minus 5, or -23. Then I go row 2, column 1. So I am done with row 1 on the first one. If you want to cross it out so you remember you're done with it, do it, so you don't confuse it. Now I'm on row 2 and I'm on column 1. Sorry, I'm writing too fast. Okay, row 2, column 1, which would be 7 times -3 plus 4 times 2. -21 plus 8, which is -13. And then the last one, which is row 2, column 2. I have row 2 already highlighted. I go to column 2. 7 times 6 plus 4 times -1, 42 minus 4, or 38.
If for number 3, A was different than B, then we would just put...
Not possible.
And then for 5, they were different, like the insides didn't match, or like
Also be not possible. Yep.
So the rules where you have to check the dimensions only is for addition and subtraction.
Addition, subtraction have to be the same. Multiplication, the middle two have to match.
Oh.
Yeah. So, Amalia, do you remember what question yours was?
Yes.
God bless you.
It was.
You have to read it to me. Okay.
So they have to be the same.
So, 7, 6 is called the inverse of a square matrix. 1, the word square means same number of rows as columns. So these are only going to be done for a 2 by 2 and a 3 by 3. So everything we look at today is going to start with those. That's what a square matrix is.
Is there anything higher?
I mean, you could do a 4 by 4. Yeah.
What are we gonna get?
No.
Or like 1 by 1? Is that kind of a square matrix?
I mean, yes, it would, but that's not one you can find the inverse of.
Oh, okay.
So we're going to learn this in 2 parts. One is like if I'm given the inverse, how to verify that it is the inverse. And then the second is actually how to find the inverse. The beginning is, like I said, if I had the inverses of each other. So if I have a matrix A and it's a 2 by 2, okay? And then I find its inverse, I give the inverse the name A negative 1. So A is the original matrix. A negative 1 would be the inverse of A. And if you took those two and you multiplied them together, the pattern should be this, which is kind of like the left side of your reduced row echelon, 1, 0, 0, 1. So if I had 2 matrices in which they were inverses of each other, and I multiplied them together in either order, so either A times the inverse, it should give me this pattern, and also the inverse times A, because that could be different, but it should give you the same pattern. So the first thing we're going to do is just check it. So if it says to show that something is the inverse, then you'll literally take the 2. So it would say A equals, and it will give you the matrix. And it will say B equals, and it will give you the matrix. And it will say show that A and B are inverses. So to do that, you will do A times B, and the result should be this. And then you'll do B times A, and the result should be this. So the prove takes 2 multiplications. You're probably not going to get tested or quizzed on the prove, but the prove is a way for you to check your answer, basically. If it's a 3 by 3 matrix, then it should result in 1, 0, 0, 0, 1, 0, and 0, 0, 1. So if I had a 3 by 3 and I wanted to check the inverse and I multiplied them together, the pattern would be that. So again, kind of the left side of your reduced row echelon. It doesn't have that last row, which would be the answers. The instructions say show that, right? This is already saying this is the inverse. B is the inverse to A. But in order to show it, show literally means prove it. And prove it means do A times B and B times A. And both times you should get the result of 1, 0, 0, 1. So it's like you already know the answer. You just got to prove it. So I'm going to do A times B first. It's a 2 by 2 and a 2 by 2. So my answer is going to be a 2 by 2. So the first one is row 1, column 1. Row 1, column 1. 2 times negative 1 plus negative 1 times negative 3. Negative 2 plus 3, which is 1. If that wasn't 1, already you'd messed up. So think about the pattern ahead of time. Then I go row 1, column 2. Row 1, but now I want column 2. 2 times negative 1 plus negative 1 times negative 2. Negative 2 plus 2, which is 0. Now I'm done with row 1. I did row 1, column 2. So this one and this one, 2 times negative 1 and negative 1 times negative 2. Now I'm in row 2, column 1. So I want row 2 and column 1. Negative 3 times negative 1 plus 1 times negative 3. 3 minus 3, which is 0. Again, that's what should go there. And then row 2, column 2. So now I'm doing row 2, but I want column 2. -3, -1, plus 1, -2. 3 minus 2, which is 1. First part, done. Now I repeat that process for BA. My brain has been so trained to go left to right that I literally have to rewrite this in that order. You don't have to do this if you can switch it, okay? But I can't use A on the left and then redo it. Like it doesn't, my brain always wants to go across and down. So if I'm doing BA, I literally rewrite A over here next to B. And now I use the BA. So I ignore the first one that's there. So again, 2 by 2 is going to result in a 2 by 2 and a 2 by 2 is going to result in a 2 by 2. First one is row 1, column 1. -1 times 2 plus -1 times -3, and I get -2 plus 3, which is 1. Row 1, column 2. -1 times -1 plus -1 times 1, 1 minus 1, which is 0. I'm done with row 1. Now I go row 2, column 1. -3 times 2 plus -2 times -3, -6 plus 6, which is 0. And then I go row 2, I'm done with column 1, so row 2, column 2. -3 times -1 plus -2 times 1, 3 minus 2, which is 1. So because I got A, B, and BA to both be in that pattern, 1, 0, 0, 1, I'm showing that these are inverses of each other. So this is, again, a way to check to see if you did it correctly. Okay, or if it said to prove it, that's what it wants you to do.
So if you need to prove it, you have to do both BA and AB.
To prove it, you have to do both. Yep. To check, I mean, if you had the time to do both, you know 100%, but at least one will get you part the way. Questions so far? All right. I'm not going to go all the way through this, I'll be honest. But I want to show you like what's different with this one. There's a scalar on B first, right? So I got to take care of that and then do it. So I would have to multiply this in to each of these, okay? And I'd get -2, +1, 3 halves, and -1 half. And then, sure. And then do A, B, and BA, okay? We won't go all the way through it because I'd rather teach you how to find these than this, but yeah.
Could you multiply A and B and then divide by 2?
Yeah, because, well, you have to do it on the B. Yeah.
Does this one not work?
Because I just did it and it works.
Yeah. As long as you do only the half on the product, yes.
Yeah,
Yes.
half is only on the product.
Yeah.
Okay.
You just can't do it to both.
Okay.
Yeah.
This one doesn't work, right?
It should. If it says show, it means it is.
Because I did it for the first one, like A times B, I got 2. But you don't have to do it.
Then you divide by
But did you do a half or?
I did. I got that.
So 1 times -2 plus 2 times 3 halves? -2 plus 3, right?
Okay.
Yeah.
Sorry.
It's okay. All right, and again, I'm not going to go all the way through this one, but we're going to talk about how you would find it, right? Now it's a 3 by 3 and a 3 by 3. My result's going to be a 3 by 3. How is it going to show that it would be it? The pattern has to be what? 1, 0, 0, 0, 1, 0, 0, 0, 1. For both A times B and B times A, okay?
So it's like reduced row echelon.
The left side of it, right, with minus the last column. Yep.
Wait, what do you mean minus the last one?
Like in reduced row echelon, we have 4 columns, right? Because the last column's the answers. Yeah. Does that make sense? Right? The rest of it's just multiplication. Are we okay to just go to the finding of the inverse? So these are all in that like check phase. All right. What you will be most likely asked for is to find the inverse. So on a quiz or test, it will say find the inverse. There are two ways to do it, okay? The first way works for both a 2 by 2 and a 3 by 3. And then I have a shortcut for only the 2 by 2. So I'm showing you the long way first, and then I'll show you a shortcut for the 2 by 2 because it doesn't work on a 3 by 3. This is how to find an inverse. So it's a tedious and complicated process, but you know how to do it because it's basically row echelon. Yeah. All right. So this whole notation basically just says to find the inverse of a matrix, you have to take the matrix and put it side by side with what you would want the result to be. So if my matrix is 1, 2, 3, 4, I'm going to take that matrix and see this. That's what this means. I'm going to put it side by side with 1, 0, 0, 1. So I put the original matrix on the left, and I put what I want it to be on the right-hand side. And then I have to use my row operations to get this into this pattern. What we've already done. I want a 1 in the top spot. I want a 0 underneath. I want a 1 where the 4 is. I want a 0 on top, okay? Now the difference is that while you're changing these cells to be this, these cells get changed. While I do all the operations, I'm going to do it to all 4, right? Whatever I do to this row, I have to go all the way across to all 4. I treat it like it's one big matrix, okay? While I'm making the changes here, for example, if I want to get a 0 here, I'm going to do -3, row 1 plus row 2, right? When I do that, these are going to get changed. Does that make sense?
So what we're trying to do is get the 4 to a 1, the 3 to a 0, and then the top.
Correct. And then once you do that, what is here is your inverse. So the changes you make to the right side become your inverse. Yeah. Just the first 4. Yep. Well, technically, yeah, it is. Yep. So, but it's only those 4 for a 2 by 2. Yeah. Okay. Yep.
We'll have a 3 by 2.
All right, let's do it. So I'm gonna only show you. I think I only have one example of this because I'd rather show you the shortcut. I'm not gonna do the second one because I'd rather show you the shortcut on this one. But we'll talk about what happened if it's 3 by 3. Okay, so find the inverse to A. I'm gonna take this and I'm gonna rewrite it. 2, -1, -3, 1. And then I'm gonna write what I want it to be next to it. 1, 0, 0, 1. It is all one matrix. So whatever I do to the row on the left, I gotta go all the way across with the row. So what is one way to start this? Because it doesn't have to go in the same order we've been used to, right? But it can.
Get a 1 in the top.
Okay, if I want to get a 1 here, how could I do that?
But don't you have to find the zeros first?
You don't have to find the zeros first, but you can. So if I skipped that 1 and I went to this 0, is it easier? Yeah. Yeah. You could do a half and I could be working and it will work, right? But because I want a 0 there, it's like going straight to Gosh Jordan. You might want to skip that first step if it makes more sense. And this time it does. Like this time, this 0 is easy.
But I'm just trying to find the 0.
You're trying to find a 0 here and a 0 there.
But you can't find the -3, 0 till you find 2 as 1, right?
No.
You can't skip that.
You can. I can multiply the top by 3 and the second by 2.
You can find the bottom 0 for the top 1.
Sure. We only put a top 1 there to help us get the zeros. You don't have to have the 1 there. Yeah. So I'm going to actually get the 0 there first because that's easy. What? That's the whole goal. Diagonal of zeros and ones. 1, 0, 0, 1. So I can add row 1 and row 2. I'm going to do it off to the side actually.
To replace row 1.
Correct. So 2, -1, 1, 0, -3, 1, 0, 1 becomes -1, 0, 1, 1. And that's going to replace row 1.
Can you multiply row 1 by -1?
Sure. So you can get the 1 here by multiplying by -1. So this becomes positive. 0 doesn't carry a sign. This becomes negative, this becomes negative. So you did negative 1, row 1. So I now have 1, 0, negative 1, negative 1, negative 3, 1, 0, 1. All I need is the 3. Good. So I need the 0 to become a 3. So 3 row, I'm going to do that to the right. 3 row 1 plus row 2. 3, 0, negative 3, negative 3, negative 3, 1, 0, 1. 0, 1, negative 3, negative 2. And that replaces row 2. 1, 0, negative 1, negative 1, 0, 1, negative 3, negative 2. So now the left side's what I want it to be, right? I get 1, 0, 0, 1, which means the right side is my inverse. The inverse to A, which would give the name A negative 1, would be negative 1, negative 1, negative 3, negative 2.
So you want to move, like, instead of it being the right side, the 1, 0, 0, 1.
You need to change it so it's the left side. Yep. And if I had the time to check this, I would multiply A times A negative 1 and see that I get 1, 0, 0, 1. Yep.
Any other ones on the other side were negative?
Right. It has to be positive 1, 0, 0, positive 1. Yep. Questions? Okay, so if this is A and I want to find A negative 1, I'm going to rewrite it 1, 1, 1, 3, 5, 4, 3, 6, 5, and then 1, 0, 0, 0, 1, 0, 0, 0, 1 on the right. You thought the other one was annoying. Now what?
Well, luckily we have a 1.
We do have a 1.
Multiply the 1 by negative 3.
Okay, negative 3, R1 plus R2. God bless you.
This is so much. Oh my god.
And that takes over row 2.
Tell me if on the quiz there's only like one question.
On the quiz, there's only one question.
Is that like only one question?
No. Yeah, of this, yeah. Okay, now what?
We won't have time. Like, that's what I'm saying. We won't have time if we have like so 3. So it's like one.
Yeah.
Okay.
Yeah. Now what?
I don't know. It's still
Something with row 3.
The same thing. Negative 3. Row 1, but this time plus row 3. They didn't have to do it. Remember I said I didn't have an example, and I said, oh crap, I have to do it later.
I think that was a blessing.
0, 3, 2, negative 3, 0, 1. All right, so that takes over row 3.
It's a lot of numbers.
That it is.
I'm trying to like mess up.
Just don't. I actually am not going to make you apply it. There is something to do with it, but I'm not. You can solve a system using this method, but I'm not going to make you do it. Okay, now what?
I'm still writing like
You can multiply by negative 1 and add if that's what you're trying to do. But I need a 0.
Then do, negative 3, 1 times row 2, and then add.
But I need a 0 there, not a 1.
So negative 3,
You need a right, but I need a 0 where the 3 is. So you can get a 1 there if that's what you're trying to do first. If you want to get the 1 there, you can.
Okay, but or just do negative 3 at the top again.
Yeah, you can't use the top because then you lose the 0.
Then you do 2.
Yeah. So both options work that you're talking about. One is to get this 1 first, multiply row 2 by negative 1 and add it to row 3. It will give you that 1 first. And then you can multiply it by negative 3 to get the 0 on the bottom. The other option is to get rid of the 3 now so I can change both rows at the same time. I can multiply row 2 by negative 3 and then add it to 2 row 3. So I'm doing negative 3 here, 0, negative 3, negative 6, sorry. Negative 6, negative 3, positive 9, negative 3, 0, and then 0, 3, 2, negative 3, 0, 1. And I get 0. I didn't multiply by 2. Hang on. And then 2, this is why you write your steps out. 2 times row 3, 0, 6, 4, negative 6, 0, 2. I know. Whining about it doesn't make it any better. 1, 3, negative 3, 2. Replace row 3.
Wow, we really thought the other one was.
Yeah.
We really thought that was bad.
Okay, now I need zeros here, here, and here, right? I can get the 1 first, but I don't need to because I'm going to have to get the 0 there anyways. So what's the easiest way to get, the only way I can get that 0?
Row 2 minus row 3.
Or negative 1, row 3 plus row 2, right?
Yes.
Negative 1, row 3 plus row 2. Yeah. Sure. I don't think anybody's ever thrown up either. No deaths and no throwing up. We don't even make first of anything today. I don't know. Because they're so excited and enjoying this so much that they're excited and the excitement is making them nauseous.
Oh, that's me.
I had my fair share of throw up on Sunday. I'm good.
Oh, thanks for sharing.
Wonderful, thank you. Lovely, Brayden.
I'm recording just so you know. All right. Now I need a 0 here. No, we're not. Yeah.
The bottom row by yours.
Row negative 1, row 3 plus row 1. 0, 0, negative 1, negative 3, positive 3, negative 2, 1, 1, 1, 1, 0, 0. Rewrite row 1.
1.
Yep. Okay, last 0 I need here. Have to use row 1 and 2, right?
Let me just stop for 2 seconds.
Mm-hmm.
Where I am.
I'm already out of space.
Sorry.
Trying to see what.
How do I get a 0 there? The only one left, this one.
Multiply.
Has to be row 2, right?
Yeah, multiply by negative 2.
Negative 2, row 1 plus row 2.
What is the end goal?
I'm trying to see where.
To get the inverse.
Oh, okay. I see.
I'm a little lost.
And you find the inverse by finding
Yeah,
all the
maybe
zeros,
we'll
like
look
to the left.
No, it's because I'm like.
Yeah?
Behind us.
No, yeah, to be with her. Not
So
to be ahead.
no difference in a way, it's just a lot of numbers.
Yep, it's the exact, you guys know this process.
Not well.
I just I'm like lost when I saw my.
All right. Shh. So now I got all my zeros, right? But what do I need? Gentlemen. Shh. The ones. I lost a 1 in that process by adding that 0 in, okay? Which is fine. I would multiply by negative a half to get that 1 back. And I would multiply by positive a half to get the second one. So I've got 1, 0, 0, 1, 1, negative 1, 0, 1, 0, negative 3, positive 2, negative 1, and then 0, 0, 1, 3, negative 3, 2. So I got the left side to be what I need it to be. The right side is my inverse. The Shortcut. Okay, so the shortcut only works on a 2x2. And it is this. You would take the original matrix, okay, and you make this little shape from it, which it's called the determinant. The book goes in weird order because the next section is determinant. But you'd multiply these two, so you're going to multiply along that diagonal first, so the top left, bottom right. And then you're going to multiply along these two, and you're going to do the first minus the second. So it would be D times A minus C times B. The A and the D and the C and the B can be reversed, but that first diagonal that goes from top left to bottom right is the one that you subtract the other from. So it has to come first.
How do you do that with 3 though?
You can't. That's what I was saying before. You cannot use the shortcut on the inverse of a 3x3. So this is something that, again, in the next section we will learn is called the determinant. When I multiply these two and then subtract from it the product of these two. One of the very first years I taught this, somebody said that shape looks like a Jesus fish. And I was like, okay. If you want to draw yourself a Jesus fish to remind you how to do it, go for it. And then she was super cute. I still remember who she is. If you put an eye on it, it reminds you that it's a minus. So if you draw your little Jesus fish and you give it its eye, it will help you remember. You just have to remember to start with the bottom right. So if I start with the bottom right, I multiply up that diagonal and then I subtract from it the other. It will help you remember the order, okay? That number is called a determinant. To do the shortcut, we put 1 over the determinant or 1 over that product, the difference of that product, and then you multiply it by your matrix modified. The way we modify it is we switch the A and the D, so D goes in the top left, A goes in the bottom right, and we change the signs on the other two, so you don't move them, but you change the signs. And this sounds so very complicated, but I promise you if you practice it 3-4 times, you've got it down. It's way easier than having to do what we were doing before. But again, it only works on a 2x2.
Is that the, why did you switch it to BA minus C?
The order doesn't matter on multiplication. Yeah, it's just that little trick, if you go bottom up, it's going to go in that order.
And then you put it under 1.
And you put it under 1.
And then from there, what is the...
And then we switch the D and the A, switch locations, the B and the C switch signs, and then the last step is to distribute in whatever you get on the outside. Yep.
I'm not even sure what you just said.
I'm going to show you, but yeah.
But if we just do D and A, D, it does not matter. Just
No, order doesn't matter there. Correct. Oh, wait, I'm going to skip and go. I'm going to do it using the shortcut. So if you go back one, that's example 5. Oh, is it?
Yeah.
Sometimes I'm smarter than I think I am, and I plan ahead. Okay. So the whole point of that would have been to do it the one way and then show you that it's the same to do it the other way. But I'm going to be lazy today because I don't want to do it the first day. I'm just going to go the shortcut. Okay. But just trust me, it would have been the same answer. Okay. All right. So to find the inverse, the first thing I'm going to do is that little Jesus fish, right, which is called the determinant. I'm going to multiply 3 times 5 and then subtract from it 2 times -2. And I get 15 minus a -4, or 15 plus 4, which is 19. Then I put 1 over 19 on the outside, and I modify the matrix. I switch the A and D, so I switch the 5 and the 3. The 3 goes in the top left, the 5 goes in the bottom right. And I change the signs on these, which sadly means it also looks like it's switched, but that's not what it is. 2, -2. Changing the signs. So switch, top left, bottom right, changing the signs on the other ones. Then I distribute in my 1/19. I'd end up with 3 over 19, 2 over 19, -2 over 19, and 5 over 19. And that's the inverse to A. So determinant, put 1 over it, switch the A and the D, change the signs on the B and the C, and then distribute that fraction. Yep.
if we're testing on this, because are we going to be forced to do
Absolutely not. If it's a 3x3, you have to do it, right? But if it's a 2x2, I would strongly encourage a shortcut. Yeah. He just said if we're tested or quizzed on this, are we gonna be forced to do the long way? And I said no, not for a 2 by 2. Obviously 3 by 3 you have to.
You can't do the shortcut.
It doesn't work. Okay, the last thing I'll show you is if you use your graphing utility to check your answers, okay? All right, so if I wanted to find the inverse of this, I'm back to the matrix menu. I go second, matrix, I go over to edit. I'm gonna enter a 2 by 2, 2 by 2. And I'm entering what I had at the beginning, 5, -2, 2, 3. And I get out of that menu, I go back to my home screen. What's the name of the inverse to A? A -1, that's exactly what you type in. Second, matrix, I hit A, and then I raise it to the -1, which is my X to the -1 button. I hit enter. Ew. How does I check that against what I just got? The little math, arrow fraction, and there's your answer. Okay?
If you would have told me this,
I did tell you this. Oh.
You know what's crazy? You said the same thing what you did. You did the same thing. You said the same thing what you